Hello everyone. Today we are having an extended session for the light bulb. So before we control the temperature of the light bulb using our Arduino code. So we explained everything, how it's working. Also the sensor we are using, temperature sensor LM35. And then we control the temperature of the LED of the immediate LED light bulb by setting our set point, and the PID block start to work to reach our desired value as fast as possible. Of course, more tuning will make our system maybe better or worse. So the tuning is always there is not just one value for PID. Of course, there are many. So here in this session, new session, it's about controlling the same system, okay, but here with MATLAB. So what is the advantage for MATLAB on Arduino? Mainly, at the first point, it's a new platform, so you know how to program your Arduino using a MATLAB. Second, it's easy for interface. So as you can see, we are not writing a syntax, a code with special syntax and some restricted with letters and sentences or maybe words, special words. So as you can see here, we are building like a block diagram. For example, here we have the summation block, here our PID block, and it's sending the output going to the plant. So here is the going output to control our Arduino, or mainly the pin that is connected to Arduino on pin 3 PWM pin. Here we are monitoring our signal, and we are sensing our here we are sensing our sensor on this side. So as you can see, it's an analog input. We are sensing it. Here I'm multiplying it by a certain value or factor. I will tell you more about it. And here we can control our system or desired temperature in real time. I will run our system and then I'll explain more. So as you can see, when I press run, okay, here is telling you it's initializing. So it's running right now in real time. Now the lamp is on, okay. As you can see here, I have my desired temperature. Okay, it's around 30, and my real temperature it's increasing. Okay, until it reach. Here we have some spikes because of the noise we are getting, but it's okay since it's a very short period of time. So I have reached my desired temperature. Okay, so as you can see, the temperature have stopped increasing, and the lamp is now off. Okay, if I increase my temperature, for example, now it's 48. So as you can see, it increased. The temperature will start to increasing since the lamp is on now, and it's heating up. Okay, and this block. Okay, so this is the PID signal the microcontroller is generating. Okay, so as you can see, it's it's a PWM signal, but you can't see it as PWM. It's just decreasing. Okay, so it's coming closer to 0. Now the lamp is off, and as you can see here, I have reached my temperature. Okay, so it's 49. Now I am 50 and half. Since I made a small overshoot, okay, I can zoom out. Okay, so since I have little overshoot, okay, I can pause my system or I can stop it. In addition, I can here tune my system in real time. So for example, now it's 20. I will run my system again. Bring this here. Let's close it, open a new one. Okay, so here I have a new one. Okay, so now I have reached my desired value, so the temperature is not increasing so fast. So for example, if I set this to 40 and press apply, okay, I need to see this output. Okay, I will show you multi graphs. Okay, so now it's 40. since the temperature is has reached its set point. Okay, so it's not increasing, so this is set point. Okay, so now everything is increased. So let's change here in the PID. So for example, it's now 40. Let's set it to 20. Okay. So it's changing the performance. Okay, so now it's increasing slowly. So if I set it to 40, for example, the LED, as you can see, it's increased. It's getting closer, but it will make an overshoot. Okay, so it became a more aggressive in reaching its set point. More aggressive, I will have more overshoot, as you can see. So هلا overshoot start around 2 degrees or more. قبل شوية before we had just 1 degree overshoot. So of course you can add I and D. So what's cool here that you can tune it in real time. So while it's running, you can keep tuning your system to find the best values. However, in Arduino, you had to upload your system every time, or in case you want to make it like this in real time, so you need to add more push buttons or some interface on serial monitor or something additional codes to have this feature. Okay, so let's stop it. First, I will let you more about this block. So as you can see in this block, I'm multiplying my analog signal from the sensor, okay, at pin 0, analog pin 0, with this factor, okay. So from where I get this constant value? By going to this image, you can see that from the data sheet of the LM35, I know that 10 millivolts will give me, okay, or it represents 1 degree Celsius. From where? From this data sheet here, mainly this point. So each 10 millivolts represent that I increased by 1 degree Celsius. Okay. So 10 millivolts represent 1 degree Celsius. For example, if I'm measuring 300 millivolts, this will give me 30 degrees Celsius. In Arduino code, in Arduino mainly board, the Nano we are using, it has 10 bits analog to digital converter, and its range is from 0 to 5 volts or 5,000 millivolts. Okay, I'm using millivolts since here the sensor give me millivolts. So from 0 till 10 bits is 1023. Okay, not it's mainly it's 10 bit minus 1 since we are starting from 0. It represents from 0 till 5,000 millivolts. So the 5,000 millivolts here are the 1023. So if I want to get an example, for example, 10 millivolt here, the 1 degree Celsius, will give me X bits. Okay, so by calculating cross multiplication between 10 and this number divided by this number, I will get 2.046. Okay, so to get to find, for example, the real temperature easily in my code, what I need to do, the real temperature, it's equal to the analog read I am getting, okay, right now, divided by the number we had here. Okay, so this number represents how many degrees Celsius I will get, okay, for each bit, or mainly each bit I have in the, not each bit, each binary number, what will it represent to me in degrees Celsius. Okay, so here the analog read divided by this number, or you can multiply it. So analog read from the Arduino multiplied by 0.48. And the Arduino code before the session before, okay, experiment before, we had this equation, which is the analog read multiplied by 5,000 divided by 10 divided by 1023. So if you calculate all of them together, you will get the same value, this one or this one. Okay. So this is how we derived this value. Okay, this value here. So as you can see, it's easy to control, more efficient. Mainly, some people will try to do more things to expand their experiment in on the MATLAB. So as you can know, in MATLAB you might have system identification, you might have more controlling systems, and easier to do, and since it's more powerful than the Arduino alone. Maybe this is the experiment. What I need you to know more is how I get these values, or mainly this code on MATLAB. So to do everything here, First, you need to initialize or launch your MATLAB. Okay, then you need to initialize or install your library. So you can find here a button or icon. It's called add-ons. So by pressing on it, you can come to here and bring the Arduino to MATLAB. How? By pressing on Get Hardware Support Packages. So when I press it, by the way, it needs internet connections. So you need to have a connection to this PC. Need to have connection to internet, so you can install packages. So there are like packages or libraries. So as you can see, there are many. Some Arduino, another Raspberry Pi, some webcams, laptops, etc. Add many. Some, for example, Android devices and cell phones. Here, iOS. Some Lego. Okay, as you can see. So what really matters for me is the Arduino. And I installed two packages. Okay, this one MATLAB support packages for Arduino, and this one Simulink support package. So you need to press on it. You'll find here an option called install. I have managed right now since it's already installed, as you can see. But in your case, you will find a button called install. So when you press it, it will ask you to log in. Logging in or having an account on MathWorks. MathWorks is the company that builds the MATLAB. So it's free to have an account. So you can build your account, then you come here and log in with it. Once you log in, it will start downloading, then installing. Then it will tell you everything is done. It's very easy steps. Okay, so when you are done, then you will go back to Simulink. So by pressing Simulink, okay, it will initialize and open a window like this for you. Okay, this is the Simulink asking you to start a new project. So you can start from blank model. You will have nothing, and you start to bring getting things from your library. Or my advice to you is to go to here to Simulink support packages for Arduino hardware. So here you have some already made models. You can start with them. So here basic model, some external model, some algorithm, how to start serial communication, how to make closed loop control system. So like the one we are using right now. Okay, and here some MATLAB code generation to get your code maybe to another thing like have a C++ code from MATLAB. Also here in examples, I think you will find more by going here also to, as you can see here. Okay, so Simulink support packages for Arduino hardware, some additional examples here about communication with Arduino, and here to use Wi-Fi with Arduino. Okay, so let's start, for example, with let's use this one to create the model. Okay, it will open this page for me. As you can see, there are some codes already here. Okay, and they are doing some. This is a reference form, waveform. It's like sine wave, and they are controlling some actuator. You need to read more to know what they are controlling, mainly motor, lamp, something else. Okay, in my case, I got an idea from how they are working and started to build my system. My system were, the blocks were outside, not like this organized very much, just to make it, easier for you to understand. But here, everything is hidden. So as you can see, there are some input, output, some visualization here. And this part, they have the plan. So more additional box you need to open. Okay, so they have some model here. Okay, so for their system. Okay. After building your code, you need to upload or to communicate with the Arduino. So to initiate communicating, you need to come here to this part. Let's move this. It's not moving. Just one sec. Does it move? طب anyway, it's not moving. ما مشكلة. We will minimize this one. Okay. So لا راحت. Okay. So you need to come here to hardware part. Okay. So in hardware part, you will find your hardware board. Since I'm not using Arduino Mega, so I need to change it. When I press on it, it will get me some options. You can start by hardware setup. So in this way, you test your board if it's working or it's communicating correctly with the PC and the MATLAB. Or if you know it's working fine, you can come here, select your board. So it will open this configuration tab or window for you. Okay, so as you can see now, I have Arduino Mega. I can change it to Arduino Nano says I'm using Nano. This Nano, by the way, 3.0. Okay, initializing the hardware. By pressing here on the target hardware and resources, you need to go. This option, keep it this way, and build, load, and run. Okay, then you go to host port connection. So you need to set the COM port. Some MATLAB versions have some auto detect, so you can press a button here, auto detect, so it detects the Arduino by itself. But this one, it's not working. I don't know really why. So you need to put the COM port. COM port, as you know, you go here to DevMan or device manager. Okay, ports, as you can see, my Arduino is connected on COM8. So by writing in COM8, okay, pressing apply. So now the MATLAB knows where is my Arduino port, which is my Arduino port. Okay. So after that, I can just press here in simulation, press run, then start working fine. Okay. So it's similar to what I have here. So as you can see in the hardware or my Arduino board, and here it's set to COM8 also. Okay. So target hardware resources, host board, it's 8. So just by pressing run, okay, it will start working. Here, by the way, stop time, it defines for how long you want to run your system. So if you want to run it for 10 seconds, 1 minute, 2 minutes, if you want to run it forever, you just write here infinity. Okay, so inf, it represents infinity, pressing run, the system is started running, going to start, not started yet. Okay, so now it's running, the LED or the light bulb is now on. Okay, you can see from here the temperature is increasing. Okay, so as you can see, the temperature is increasing since the light is on. So this is everything about MATLAB. Maybe not everything. It's just a small part on how to control Arduino, but this is everything for our experiment. So to know more, to know more about Arduino and MATLAB, you can explore more on the internet. They have many helps. They have some different examples, and there are a lot of resources online. Okay. So good luck and thank you.